So the last learning objective in Unit 5, woohoo! Okay, is learning objective 26, which is to compare and contrast between properties of the three types of compounds. So all compounds are defined by their difference in electronegativity. So their differences in electronegativity determine what type of compound that you have. So for nonpolar compounds, what happens to the electrons? They are shared. And it's an even sharing, so we'll put even in here, even sharing. For a polar compound, it is, again, a share. We're sharing electrons, but it's uneven. So that's the big difference between polar and nonpolar. Polar have an even sharing of electrons, nonpolar have an uneven sharing of electrons. Ionic compounds transfer. Differences in electronegativity. So the difference in a nonpolar is 0 to 0.4. We could say for a nonpolar compound, CH4. Carbon has an electronegativity value as 2.55, and hydrogen has a electronegativity is 2.20. So 2.55 minus 2.20 would be 3.5, so 0.35. So this really shows you carbon to hydrogen compounds are nonpolar because it is in between 0.0 to 0.4. Now, if I were looking at a polar molecule, so it would be from 0.4 to 2.0 difference in electronegativity. So H2O, we know that that's a polar molecule. Again, hydrogen has a 2.20 electronegativity. Hydrogen has a 3.44 electronegativity. So the difference in electronegativity between hydrogen and oxygen, 1.24 electronegativity difference. So that 1.24 falls in the range of polar compounds. Now, I would give you this, I would give you the actual values for the electronegativities if I were asking you about this. So don't worry about memorizing electronegativity values. I will give you the values if I'm asking you what type of compound you have based on electronegativity. So you don't have to worry about memorizing your electronegativity values. I know you probably were. And then, so for ionic, it's going to be anything greater than 2. So you have greater than 2.0. So for instance, sodium and oxygen. So if sodium and oxygen come together to form a compound, again, oxygen's value is 3.44, whereas sodium's value is 0.93, which is 2.51. So that falls within the ionic range. Ionic range. Now, again, this is a sliding scale, so it really depends on what you have bound together. So like if I've got like sulfur and sodium, that might be more of a polar compound instead of an ionic compound. It really depends on like what you have that are bound together and are forming the compound. So conduction of electricity in the solution. So nonpolar compounds will never conduct electricity in solution. Polar compounds, slightly. It might happen, and that's really if you've got a very weak acid, and you will have some conduction of electricity there. Ionic will always conduct electricity. There are some exceptions. So like if you've got an ionic compound that does not dissolve, no, it is not going to conduct electricity in the solution. It really depends on, does it dissolve or does it not dissolve? What do the compounds dissolve in? So for a nonpolar compound, they are only going to dissolve in nonpolar solvents. So what that means is that if I've got a nonpolar compound like oil, I'm going to have something that is a nonpolar solvent to dissolve that in. So it's got to be similar to the oil itself, or it's not going to dissolve. So oil and water separate because water's polar and oil is nonpolar. So when you have nonpolar to polar, they are not going to mix very well, whereas two nonpolar substances will mix very well. A polar compound will dissolve in a polar solvent, like water. And the same is true for an ionic compound. It has to have a polar solvent to dissolve. Relative melting points. So the lowest goes to nonpolar. Nonpolar are going to have the lowest melting points and the lowest boiling points. Your polar compounds are going to be intermediate, and your ionic compounds are going to be high. Primary state of matter for the compounds at room temperature. For a nonpolar compound, the nonpolar compounds are either going to be gas or liquid. A polar compound is going to be either a liquid or a solid. Most ionic compounds are solids. Okay. That is the end of Unit 5. So this was Learning Objective 26, which is the end of Unit 5, which was to compare and contrast between properties of the three types of compounds.